Okay, welcome back. Part 2 of quadratic functions, characteristics of quadratic functions. So we start with something called, we're going to have a lot of vocabulary, so get ready for vocabulary, maybe even, be ready to write these things down so that you have reference to them. Zero of a function is when the y coordinate equals 0. The x values when y equals 0 are called the zeros. So think about your coordinates. If y is 0, x is something else. X could be 0, x could be 2, x could be anything. But you have an x value and a y value. I'm just telling you that when y is 0, that's called the zero of a function. There can be no zeros, so 0 zeros. There could be 1 0, and there could be 2 zeros. 1 0 means that the vertex is on the x-axis, so it's already touching the x-axis once. 2 zeros means that your parabola has gone through the x-axis. That means the vertex was above the y equals 0 or below it. And now your parabola crosses through the x-axis twice. Or you could have no zeros at all. If your parabola, let's say, has a minimum of y equals 2 and opens upward, you're never going to cross the x-axis at all. Here are many examples. To begin with, here is 1 0. Let me introduce another word to you, the axis of symmetry. So think we're all the way back to kindergarten when you made a heart and folded it in half and you had your line of symmetry. But we're going to call this our axis of symmetry, which is the invisible line that is vertical to your vertex. Here I have 1 0. Over to the right, 1 0. It crosses the x once. Crosses the x twice. I have 2 zeros here. Here's my axis of symmetry, and here are my 2 zeros. This parabola opens upward. It, again, has a minimum, so it crosses the x-axis twice. My last 2 on the bottom have no 0 at all. They never cross the x-axis. They have a maximum below the x-axis, a minimum above the x-axis. But notice that all of them have an axis of symmetry, which is clearly going to be important, or I wouldn't have it there to begin with. The axis of symmetry is the line dividing the parabola in half, passing through the vertex. This dashed line above is the axis of symmetry. Your axis of symmetry is the x value of the vertex. How do you find the value? How do you find the axis of symmetry when you have 2 zeros? Well, you add up the 2 zeros and you divide by 2 because it's the middle, it's the center. You have your x-coordinate of the vertex and the axis of symmetry. So x sub 1 and x sub 2 are where the parabola passes through the x-axis, and those are your 2 zeros. Finding the axis of symmetry when you have 1 0. Well, now it seems pretty simple because it is the x-coordinate of the vertex. My 0 is wherever I am, the x-coordinate. So I don't have this one labeled as a number line, so I can't tell how negative I am, but whatever my x-coordinate is of this vertex is my 0. Finding the axis of symmetry with no zeros, or what if you just can't figure it out? Well, lucky for us, the mathematicians in this world gave us a formula. You notice how we never get the formula until after we learn how to do it the long way? Same thing's going to happen here. X equals the inverse of b divided by 2a. B and A come from the formula y equals ax squared plus bx plus c. This x value is the x value of the coordinate of the vertex, and it is the axis of symmetry. You can substitute this x value into the quadratic equation y equals ax squared plus bx plus c, and you could solve for y. So if you know what this x value is, you can plug it in and you can actually solve a quadratic equation. This y value will be the second coordinate of the vertex. Remember, a vertex is in x, y form. It is a set of coordinates. This is a lot to take in. Please feel free to watch this video several times. I know it's inspiring, but I need you to really understand it before we move on. Example, y equals 2x squared plus x plus 3. Find the axis of symmetry. Okay, I'm going to use my new shortcut formula. Inverse of b, invisible 1, over 2 times a is another 2, so 2 times 2, the inverse of 1/4, obviously that becomes negative 1/4. Substitute in negative 1/4 for x. So, of course, wouldn't you wish I had chosen a number that would come out even and not a fraction, but no such luck. I replace x with negative 1/4. I substitute and solve all along the way. My answer, y equals 2 7/8. Remember, this software doesn't allow me to do fractions easily, so I'm sorry that sometimes I don't always use a fraction bar. My coordinates, negative 1/4, because right here we know x equals negative 1/4. My y value is the one I had to calculate, 2 7/8. Notes. Use the formula inverse of b over 2a to calculate x. Replace x into the quadratic formula, ax squared plus bx plus c, to solve for y. And you will have the coordinates of your vertex. The a coefficient tells you if the parabola opens up or down. The x value of the vertex is also the axis of symmetry. You can determine the number of zeros by graphing it. If you know the direction of the parabola, then you can determine how many zeros there will be. However, you will not know the actual value of the zeros. You will only know how many there are. So let's try some. This is your chance to pause the video and do a little bit of scratch work on the side. I would like you to find x. Remember, we're going to use that cute little shortcut, inverse of b over 2a. So let's go ahead and plug in those values. Go ahead and stop my tape. Welcome back. I know some of you didn't stop the tape, but you really should. It's really important that you practice some of these. Here are my answers. I did not show you the work. I'm sorry for that. I wasn't prepared that I was doing these all on video. These are just our regular notes where I would normally be drawing all over the board in the classroom, but you do have your answers. So make sure that you did your inverse of b over 2a, and that you should have been able to solve that and get 1. Good luck, and please practice. Every section we do is going to build upon this and, of course, get harder. I need you to be ready for that. Bye now.